So good morning, friends. So the session which we are going to start now is about SCADA. So first we will see a general introduction about SCADA. What is the use of SCADA in industry? What and all we are going to do with the help of SCADA. And after that we will see how to develop a process in SCADA. Because if you know the basics of SCADA, then only you can understand the other things. So first I will cover what and all can be done with the help of SCADA and what and all we have to do with SCADA for industrial process automation. So generally, this SCADA refers to supervisory control and data acquisition. Supervisory control and data acquisition is only called as SCADA. What is the meaning of each and everything? First, we have an option called a supervisory. Next, we have an option called control and data acquisition. So what is this supervisory? What is this control? And what is this data acquisition? We will see that now. So generally, if you see SCADA, it is not any hardware and all. It is just a software. Okay, so it is a software which has to be installed in a PC, our laptop or any computer which is used in industry. And what we have to do in that, what we can do with the help of SCADA means, we have already gone through what is a PLC. So PLC is a hardware which is going to control the process, control the industrial process which is happening in the field location. For example, just assume I have a process. That process is going to be controlled with the help of a PLC. So PLC is completely taking charge of that particular process. If you do the program for the PLC, if we give the inputs and if we connect the output of the process, what will the PLC do means PLC will completely control the process. Now, just assume process location is, for example, it is some 100 meters or 200 meters like that. So complete process is happening in that location. PLC will be available nearer by the process. The PLC will be controlling all the process together. Now, just assume you want to know what is happening in the process. You want to know what is happening in the process. Then what we have to do is we have to be physically present nearer to the process. If we are physically present nearer to the process, then only what we can do is we can know what is happening in the process. I have to go and check each and every equipment. I have to go and see what is happening in the process like that. So each and every data I have to manually take note of it in a piece of paper or in a notebook like that. If you want to know each and every process status, I have to check each and every equipment and note down the status. If you want to control the process also, you have to be in the field. Field means process location. Then only you can know what is happening. You will be using different equipments for controlling all those things. But if we have this SCADA, what is the advantage means? We can do all these three things together, that is supervisory, control and data acquisition. Supervisory means nothing but monitoring the process. So what we can do is we can monitor the process, we can control the process, and we can collect the data. So all these things can be done from any remote location. Remote location means it is not necessary that I have to be physically present in the process location. I can be anywhere else in the either in the process location or it can be any part of the world also. Just assume process is located in some 5 kilometers apart, but I can be here and know what is happening in the process. So how it can be done means, I said no, this SCADA is a software. This software has to be installed in the PC, and that PC has to be communicated with the PLC which is controlling the process. So there is a controller PLC. That PLC has to be communicated with this SCADA PC. So after communication is taken place, what can be done means we can monitor the process from any remote location, we can control the process from any remote location, and also we can collect the data from any remote location. Remote location means from any part of the world, we can do all these things together. So that is the advantage what you have in SCADA. So one by one, how it is possible, how we can do all these things, we can see one by one. So as I have mentioned earlier, SCADA is a software. So it is otherwise called as industrial based computer control system, by using which we can monitor the process, we can control the process from any remote location, and also we can gather the information, that is we can collect the data. We can collect the data in any format, like it can be in number format, it can be in text format. We can exchange the data in Excel. We can take the data, record the data, and we can store the data for any future reference also. All these things can be done with the help of SCADA. So what is happening nowadays in modern SCADA, all the real-time data can be got with the help of SCADA from any part of the world. So any part of the world, how it can be done means through suitable communication protocols. For example, nowadays using internet, what we are doing, we are gathering all the information which is happening somewhere else from any part of the world, right? The same thing can be done with the help of SCADA also. So that is the advantage what we have in SCADA. So if we see, SCADA is used in most of the sectors like oil and gas, power plants, steel plants, like that. In most of the process industries and very large scale industry and all are using this SCADA to do all these things. So what will happen is, if you know the architecture of SCADA, then you can know how it can be done. So what will happen is, in the process, if you have a process in any industry, that will be called as the field data. So field data or field process. So that will be the lower level. That will be the first level in the process. So from that, what will happen? It will go to the next level. So the next level is, I said I have the process, that to control the process, I will be using some field devices like valve, transmitter. To measure the level of the tank, I will use level transmitter. To measure the flow, to measure the temperature, I will use different types of transmitters and different types of devices. So all those devices will be called as field devices. Now, who will control these field devices? Means our controller. So in our case, we can consider that as PLC. So PLC is going to control the field devices. So based on the control of the field devices, what will happen is the process will be getting controlled. Now, the process is getting controlled with the help of these field devices, which is controlled with the help of controller, that is PLC. Now, this is called as field process location. So this is only called as our process location or field process. So this process, if we want to monitor, we have to be physically available here. So wherever our process is happening, we have to be physically present. Then only we can know what is happening in the process. But if we have SCADA, what we can do is, we can do all these things with the help of suitable communication network. So what we have to do, the next level is monitoring and control, and after that the final level is database collection. So they will be controlling and they will monitor the process. For example, just assume the field technicians, service engineers, maintenance engineers, all those persons will be available in the physical location. But the managerial category persons, the engineer level category persons, they and all will be sitting in a control room. So this area will be called as a control room. So this already I have said, this is called as the field process location. This will be called as field, and this will be called as the control room. So from control room, what and all we will do means, we can monitor the process, we can control the process, as well as we can collect the data. That is only database collection. So what will happen? The management will collect the data and they will schedule according to the data. They will compare that data with the process they need. So they will be comparing that process, and after comparison, what they will do is, okay, this much it is less, or this much it is more. So we have to stop the production, or we have to increase the production, like that. They will be giving the schedule for that, and that schedule has to be given to the next level, that is production control team. So what they will do, they will control all these process according to this schedule, what and all measures they have to do. So that measures they will do and give it to the next level. So that technician, field technicians, maintenance team, according to the information they have received from the higher category, they will be doing all these things. So this is the architecture of SCADA. So here only that SCADA will be available. SCADA will be available at this location, and the controller will be available here. So these two things has to be communicated together using suitable communication protocols. And after doing all these things, not only communication, I said this is SCADA, right? So in the SCADA PC, what we have to do, for example, according to our field process, whatever data are available, or for example, I want to monitor the conveyor movement, I want to monitor the tank filling. So all these designs has to be done in SCADA. So same as this tank, the design has to be done. Same as the conveyor available here, the design has to be done in SCADA. So don't think we have to sit and design it like paint. It is not like that. All the predefined components like conveyors, motors, tanks, valves, pipes, all these things will be available in SCADA library itself. So from that library, what we will do, we will collect all those objects which are required, and we will be doing that schematic layout. That's all. So that schematic layout has to be done in SCADA, and after that is done, what we have to do is we have to communicate that layout which we have did in SCADA with the field process. So field process means field process is controlled with the help of a PLC. So in PLC we will have communication protocol. So this communication protocol which is available in the PLC, the same has to be available in SCADA. Or what we have to do, in SCADA PC we will have some communication network. If it is internet, Ethernet protocol, what we have to do, we have to convert this to Ethernet. We will be using proper converters for communication, and after that only we will be communicating this. Now in PLC, what will happen, all the field devices, inputs and outputs, everything will be getting connected here. So all these things, all the data will be available in the PLC. So where it will be available means in the address. So there will be separate memory location address where all the data will be available, and all those addresses has to be given in SCADA. Then only what will happen in the field, if there is any change, that change can be reflected in SCADA also. So all these things are going to be done with the help of SCADA. So this is what about the introduction of SCADA. Now so the next part, this is how the control room will be. Okay, so if you see what is happening in the field process, I said all the process are going to be monitored. This is the SCADA PC. They have installed the software in this, and same as the field process, they have designed the process here, and here all the inputs and outputs, everything is available here. So from here also what we can do, we can control or monitor the process, and even we can collect the data. So internally, if you see, these are all the different designs we have to make in SCADA, like tank or pump or pipes, valves are there. So all these data, how we can connect means, I said the PLC is connected with SCADA. So PLC is already controlling the field devices. So all the devices status will be available in PLC memory. That memory has to be accessed from SCADA. If we access that PLC's memory, input and output memory addresses, then only what we can do, we can collect the data, and same as the process location, here also we can monitor each and every information. So like this, what we have to do, if we want just the values, it can be like this, or if we want separate animation also, for that means that animation creation also can be done with the help of SCADA. So this is how the animation creation will be. So all those things we will see, like how to create the animation. There are different properties for that. If we have a conveyor, we have to move the object. If we have a motor, we have to rotate that. Like that, different types of animations are available. So all those animation, how it has to be done, like that, step by step, we will discuss in this session. So this is the hierarchy of process control. Like just take, this is the process which we have. This process has to be controlled with the help of our PLC. So see here, the complete, this process is the complete process which we have. See, from the initial stage, from the raw material handling, next it is going to process tank. In process tank, all it is getting mixed, and what is happening, it is filtered, it is purified, and from there what is happening, it is going to the filling tank. From filling tank, what is happening, there is a conveyor here. This conveyor will start and stop according to the requirement. After the bottle is getting filled, it is going to the next section. This is the capping section. After that, capping is happening. So here, see, finished goods handling, like packaging section. So for each and every process, there are separate controllers. See, separate controllers are there. This is one PLC, this is one PLC, this is one PLC, like that. For every process, separate PLCs are there. So this PLCs has to be communicated together with the help of SCADA. So see here, all the PLCs are communicated together, and from there they are taking to the supervisory. See, supervisory means SCADA only. So supervisory HMI means it is SCADA. So what is happening? All the processes are getting monitored with the help of SCADA. So this is how the process hierarchy will be available if you have SCADA. So based on the requirement, they will be doing. So I said the process has to be designed in SCADA, right? So this is how they will be designing and creating the animation. So the same process will be happening somewhere else, but what we can do, sitting from the control room in front of the SCADA PC, what we can do, this is the level, this is the temperature, this is the pressure, or if you want to start or stop the process, so from here itself we can do. If you want to open the valve or close the valve, from here itself you can do. So for that we have to do some configurations. So what are all the configurations we have to do with the help of SCADA? All those things we will be discussing. So these are the different things. So as I said earlier, the field process, they have designed the same way. How the field process will be available, the same thing they have designed in SCADA. After designing, what they have to do, they have to interlink this design with the field controller. So we can take this as a small example. So see here, I have a conveyor here, I have a forward motor, I have a reverse motor. Here you have job in sensor, job out sensor, and here you have forward push button, reverse push button. So now this is my field process. So to control this field process, what I have is, I have a PLC. So let's take, I have a PLC here. This PLC has to be controlling the process. Means what I have to do is, I have to connect the inputs and outputs. So based on what I have to control the process. So job in sensor should be on, then only forward motor will be on. This is my condition. So whenever I place any object here, what will happen? Automatically this sensor will sense the object because it is directly in contact with this. So the sensor will sense the object, and after it is sensing the object, if I press forward push button, what will happen? Automatically this forward motor will be on. So if forward motor is on, object will be started moving here. So for this, I have to do the program. Next, when the object reaches this position, what will happen? This job out sensor will be on. When job out sensor is on, automatically forward motor should on. And if I press reverse push button, what should happen? Reverse motor will be on. So object will move in this direction like that. I have to do the program. So what will happen is, this job in sensor, job out sensor, start forward push button, reverse push button, all those things are the input for PLC. And what are all the output? Forward motor and reverse motor are connected as the output for the PLC. Now what we have to do is we have to do the program. So according to my condition, if forward push button and job in sensor are on, I have to run the forward motor. So I'm naming this is job in sensor, this is forward push button. When these both are on, I have to run the motor, but these two are not continuous input. I have to continuously run the motor because I will not press the push button continuously. If I take my hand back also, I have to run this motor continuously. So what I have to do, I have to latch this with the forward motor like this. So what will happen, even if the sensor is off also, continuously the motor will be on. So I have did the program like this. Now if job out sensor is on, forward motor should be off. So this is job out sensor. So like this, what we have to do, we have to do the program for all this process, and after doing the program, what will happen, this PLC will automatically control the process. So PLC will be controlling the process based on the program what we have did to the controller. Receiving these inputs, it will control the output. Now what I have is, I have SCADA. Okay, so see here, I have SCADA. So this SCADA software I'm going to install in a PC. So this PC is available apart from the process. Just assume this is the field process. Field process is available in one location, and this control room in which I have this SCADA is available some 1 kilometer apart from the field process. So how we have to communicate? Here in this PC, we will have some communication network. So using that communication network, what I have to do, I have to communicate that with the PLC communication protocol. So for that, we will use different mediums here. Either it can be LAN connection or any Ethernet connection, internet connection, like that. I have some communication. So based on the communication, I have connected this PLC and the field process. Okay, after communication, what I have to do is, I have this design, right? This conveyor, this object, job in sensor, job out sensor. Same like that, I have to design the process here. As I have said earlier, all these designs, no need of drawing this, all these will be available in the SCADA library itself. So from that library, I have to pick all those designs and paste it here according to the requirement. So after designing all these things, what I have to do is, I have to give a name for interlinking this design with the PLC. So what I have to do, for that, I have to give a name called tag name. So this tag name is nothing but it is used to interlink the design what I have in SCADA with PLC, because PLC is only having all those data. So what I have to do, for each and every design what I have made in SCADA, for that I have to give separate name. For example, for this I am giving a name, sensor 1. So this is the tag name for sensor 1. So after giving the tag name, what I have to do is, for each and everything in PLC, I will be giving some address. For example, I am giving X0 for this, X1 for this, Y0 for this. So based on the PLC, this address will change. For example, I am using AB PLC, means address will be I:0/0 for input. For the next input, I:0/1. For this output, it will be O:0/0. So what I have to do, after giving the tag name, I have to give the address also here. So tag name is nothing but it is the carrier of the address and the data. It is nothing but the carrier of the field data. It is the carrier of the field data. Carrier, how it is carrying that address values means, for example, if the sensor is on, it will store the value as 1. If it is off, it will take the value as 0. So how it is means with the help of address. So with the help of address, because in the address only the data will be getting stored 0 or 1 like that. So that values only will be available in SCADA here. So what will happen in the field, if there is any change in the value, automatically it will get reflected here. How it will be getting reflected here means we have to create some animation for that. Animation means, for example, if it is off, it should be in one color. If it is on, it should be in one color. Like that, I can create some animation. I can create, if it is off, it should be in one color. If it is on, it should be blinking on and off, like that it should be blinking, like that. Different types of animation I can create. Same way for object also, object has to be moved when the motor is on. For that also I can create the animation. So all these things only we are going to do in SCADA. So the field process is controlled with the help of SCADA, PLC. That PLC is communicated with SCADA, and after communication, we have to design the process, we have to give the tag name, and we have to create suitable animation for that. So based on that, what will happen is the SCADA will be, with the help of SCADA, we can monitor the process, we can control the process, and we can collect the data. So what is this data collection? How data collection can be done means, I can communicate this SCADA. All these tag names I have given with the help of address, no? So all these things can be communicated with, for example, I want to exchange the data to Excel sheet. So with that Excel sheet, I have to store all the values available in that. So that also can be done. So I can transfer all the data from SCADA to Excel sheet. I can transfer all the data from SCADA to MS Microsoft related application, MS Access or Excel, like that. And for example, if you want to monitor all these data, like all these things here, I have said like it is on and off process, but we have analog process also, like tank level, pressure, all those values can be monitored with the help of SCADA. So that value monitor also can be done. And also we can monitor all these values with the help of a graph also. Graphical format monitoring also can be done. We can create alarms for each and every condition. So what will happen if I have set alarm for low level or high level, alarm also will be monitored with the help of SCADA. So like that, many applications can be done with the help of SCADA. So each and every applications only we are going to discuss, and how to create animation with the help of SCADA. That is what we are going to discuss now. So like this type of process can be done, like a tank level monitoring and control. When start push button is on, this pump will be on. If pump is on, inlet valve will get opened. After that, if low level sensor is on, tank level will be getting increased. If high level sensor is on, pump will be off, inlet valve will be off. Like that, we have different process now. So for all these things, we can create animation and monitor this process with the help of SCADA. So all the designs, this design, like that, different designs I have made here. No, all these things are done with the help of SCADA only. So this is what we are going to discuss now. How to do all these designs with the help of SCADA. Okay. So now I'll say you, we have many modes of operation in SCADA. Modes of operations. So what are all the different modes of operation? Means normal. One is simulation and the other one is interfacing. One is simulation and the other one is interfacing. Normally, if you do any process in simulation, what we will do is, for input and output, we will give same tag name only. For input and output, we will give a same tag name. But in interfacing mode only, what we will do is we will give different tag name. Why? Because in interfacing mode only, we have the PLC with us. In simulation, we will not have PLC, just we will design the process in SCADA and we will check it like a demo. For example, for showing your real-time process, how it will be working, all those things, if you want to show it as a demo also can be done with the help of SCADA. Because in simulation mode, we don't have PLC, we have only SCADA. So if you want to interlink the input and output, how it can be done means, for that we have to give same tag name. For example, I have a switch and I have a lamp. If the switch is on, this lamp should be on means I will give, after designing the process, I will give a tag name. For example, for switch, I am giving SW as the tag name. For lamp, I am giving LA, like this one tag name means it will not be interlinked. It cannot be interlinked. So for that only, what we have to do, for input and output, we have to give same tag name. For example, for switch, I am giving SW means for lamp, I have to give same SW because it is simulation. Simulation means only SCADA. Okay, only SCADA. But interfacing means we will have SCADA with PLC. So at that time, what we can do, in PLC we have separate address. So what will happen automatically, that address data will be reflected in SCADA because SCADA will be communicated with PLC. So for this, I am giving SW means for this we will give separate address I:0/0. For lamp, I am giving L1 means for this I will give O:0/0. So here, if the data is 1, we will do the program in PLC for that. If switch is on, lamp is on means based on this it will get reflected here. So now, if you are just doing in simulation, don't forget we have to give same tag name for input and output. But in simulation also we have another one option for giving different tag name. At that time, what we have to do is we have to do separate programming for that using script. We have to write script for that. Script is nothing but a programming language used in SCADA. It is a programming language used in SCADA. Script is nothing but a programming language used in SCADA. So with the help of script, what we can do, we can give different tag name also in simulation mode. I will explain each and everything. First, I will give same tag name. After that, we can see some applications, and after that, we will see what is script and how to give different tag names for every process. All those things we will see together now. Now, in SCADA, if you see, we have different softwares. SCADA softwares. We have many SCADA softwares. For example, we have Wonderware InTouch. Wonderware InTouch is a SCADA software which is manufactured by the company called Invensys. We have WinCC. WinCC SCADA, company name is Siemens. Like that, many SCADA are there. CX Supervisor. CX Supervisor SCADA is Omron. Like that, many SCADA softwares are there. So here, about which SCADA software, most popularly used SCADA software is Wonderware InTouch. About this Wonderware InTouch SCADA software only we are going to discuss completely. How to create animation in that, how to design the process, how to interface with field devices, and how to interface with the SCADA. All those things we are going to discuss now. So we are going to start with that SCADA software. So I have already installed this software in my PC. So after installation, I will show you the procedure also for opening all these things. After installation, you can search InTouch and you can open it. So after opening, what will happen means this InTouch application manager window will get opened. So what is this InTouch application manager window means? In this only we are going to design and store all your projects. Okay. So here projects are also called as applications. So only it is showing as application manager. It is nothing but your project manager where your projects and all will be available. So here already I have different projects which I have did earlier. Now if you want to create a new project, what we have to do, go to file, select new and create a new project. So you can select, you can browse and select at which location your data has to be stored, everything. So after giving that, give next, and here what you have to do, here you can give any folder name where the data has to be getting stored, where your project has to be getting stored. So I'm just giving today's date, like March 29, like this. I'm giving. After giving it, give OK, and here it is asking for project title. So I'm just giving project like this. So after giving the project name, if you give finish, see what is happening. It will be getting created here. See, under this D directory, under InTouch, March 29 is the folder name, and here this is your project. So it is showing, see, name of the project, everything it is showing here. So if you want to open that particular project, what you have to do, double click this project. So what will happen? It will get opened. The SCADA designing window will get opened. See, Wonderware InTouch window maker. This designing page will get opened. So window maker is nothing but the designing page. Now here you have opened this window maker, and in this window you are going to create a new window according to your requirement. So go to file, select new window, and in this window I'm just giving window 1 as the window name, and you can give the size. For example, I want this size and this height, this width and height in this window. So that also you can give. I'm giving 1248 1024, like this, some size I am giving. So what will happen, based on the size what we have given here, according to this it will get opened. So in this window only you are going to design the process. So as I have said earlier, no need of sitting and designing it manually. All the designs will be available in SCADA library itself. So here, which is the library means, here you can see one option, wizards. So wizards is nothing but the SCADA library in InTouch. So click wizard. Now for example, I need just a simple design, switch and a lamp. So here can you see there are many designs, buttons is there. I need switch, so I'm selecting switch here. I'm selecting a particular switch, knob switch I'm selecting, give OK, and if you click here, that switch will be appearing here. Now for example, I need a lamp also. So here you have wizards, you have different lights here. So select round side, and this light I am selecting. It is available here. Now what we have to do, after designing this, we have to give separate tag name for this. Okay, I have designed this, I have to give tag name. So now I am not going to interface this with PLC, I am just doing it in simulation. So what I have to do, for this is the input and this is the output. If this input is on, this output should be activated. So what I am going to do, I am going to give a tag name for this switch. So I'm just double clicking this switch and I'm going to give a tag name. See, tag name it is asking. I'm giving it as S1. Okay, so I have given the tag name as S1. After giving the tag name, if you give OK, automatically it is showing, see, define S1, give OK. So you just save it and close. Just save and close it. So automatically what is happening? The data will be getting saved in this S1. Now here, this is input. If this input is on, this output should be activated. As I said earlier, it is just simulation. So give same tag name. So double click this light and here also give S1. So here it is showing for off it will be in red color and for on it will be in green color. If you want, you can enable that blink option also. Now I am not enabling blink because for off one color I have given, for on one color I have given. So give OK. So S1, here also S1 I have given, here also S1 I have given. Now what is going to happen here means, I'm going to check this, whether this input is on, whether the output will be on. So at the top, can you see at the right side, you have an option called runtime. So click runtime, give OK, ignore, and again if you give OK. So previously it was in InTouch Window Maker. Now it is in InTouch Window Viewer. So what should happen if this input is activated? Automatically, see here, lamp is also on. If input is off, lamp is off. So this is how you will be creating the animations for designs. Now if you want to return back to editing page, window maker page means at the top right side corner you have an option called development. So if you click this development, automatically it will return back to this page. So here what designs I have means I have input and output, but this is just on off process. On off process means it will be on or off. But now I am going to design some analog process. So for analog means it should be a continuous range, temperature, pressure, like that. So tank level, like that. So for that I have to give a input. So for giving the input, for analog input I am going to use slider. So if I manually vary the slider, what will happen? Automatically the level of the tank, the pressure, everything will get increased. So I have used the slider here. Already I have given S1 for this. This is digital input. So this is analog input. So what I'm going to do, I'm going to double click this and I'm going to give S2 for this. Another tag name I have given. Give OK. See here it is asking for minimum value and maximum value. So don't forget you have to give minimum value 0, maximum value as 100. After that save, close. So slider I have given. Next I'm going to give a meter, like analog meter for that. So here under meters, see here you have speedometer, you have panel meter, you have LED meter, thermometer, like that. Speedometer for measuring the speed. So I have taken that speedometer, I am double clicking that, same S2 has to be given here. So minimum maximum value I am giving 0, 100. Now see here, if I go to runtime, if I vary this, automatically the speed changes also, it is showing. So these are the predefined designs which is available here. But what I can do, I can create some other designs also, like I want a tank. The level of the tank should be getting increased. So where the tank and all will be available means here, same, select wizards. From here itself, if you are taking all these things, that are all predefined designs. You have to just give the tag name, that's all. But I said we can create animations also, no? So for creating animations for different designs, that type of designs like conveyor, motor, tank, valve, all those designs will be available under this symbol factory. So from this symbol factory, what we have to do is we have to take all those designs and we have to create the animation for that. So whichever design you are taking from symbol factory, for that only you can create different types of animations. So I have opened this symbol factory, and from this I am going to search for tanks. See, there are many types of designs available here. Blowers are there, boilers are there, buildings, chemical mixtures, computer hardware like that, containers, controllers, conveyor belts, conveyors, ducts, like that. Many types of designs are available here. So from this I am going to take one design, like I'm going to take a tank. So see, if you see here, tank is available here. I can select any one of this tank from here. So I have maximized the size of the tank, and now here I have to give the tag name and I have to give fill property. I have to give filling property for this. But if I double click this, again this symbol factory design is only getting open. So what I have to do, whichever design I have taken from Symbol Factory, I have to follow a procedure. So this design I have taken from Symbol Factory. So what I have to do, just right click this design, go to cell or symbol and select the option break cell. Break cell means then only what will happen, this design will be taken from that Symbol Factory and it will be separated from there and it will be placed here. Now I have breaked it. Now if you double click, see there are many types of animations available here. Different types of animations are there. So from this, I want to give one animation which is specifically given for a tank. So for tank, what type of animation I can give means I can give filling animation, fill property animation. So what you have to do is just to double click the tank now. See, can you see here there is an option called percentage fill. So this percentage fill has to be given here. So percentage fill vertical, like that I am giving. So click this vertical and here there is an option called expression. So under this expression you have to give the tag name. So I have given S2 for this particular slider. So I am giving S2 here. So see here, for slider it was minimum value was 0, maximum value was 100. From bottom to top only you have to give. See here, because from bottom to top only the tank will be getting increased. So 0 to 100 I have given, minimum value 0, maximum value 100. This is left side limit, your slider limit. Left side limit is nothing but your slider limit. Slider means your analog input limit. And what is the right side limit? Here also 0 to 100. This is nothing but your tank limit, tank filling limit. So input limit and output limit I have given. After that, what you have to do is direction of filling, up direction or down direction filling. You have to give. I am giving up direction filling. So give OK. So see here, it is enabled here. Now if you go to runtime, so see what is happening. If you increase the slider, automatically the level of the tank is also getting increased. If you decrease the slider, the level of the tank is getting decreased. So like this, what I can do is I can give different animations for the process. So this is how we can create different types of animations for the process. Now I have given vertical filling. In case I am removing this vertical filling, I am disabling that. I am going to give horizontal filling. So horizontal filling here I am giving S2. So after giving that horizontal filling, if you give OK, the same tank now it will be filling horizontally. See, horizontally it is getting filled. But this horizontal filling for this tank it is not necessary, but for any other thing. For example, I want to fill a pipeline. I want to show the filling in a pipeline. It is horizontal pipe. So for that and all, what I can do, I can give this horizontal filling property. So like this, you can use this types of animation for designing and seeing the process like a real-time process. So this is how you will do that animations and all. Now, for example, tank level is getting increased. So for that, I am using this type of property. I want to move an object. Just assume here in this line, there is a line here. I want to move this object in this line. So for moving the object in this line, just double click this object. I have taken the object from here. I am creating a rectangle. This is my object now. If you double click here, there is an option called location. So location is for moving the object either vertically or horizontally. Now I want to move this object horizontally. So double click this object, go to location horizontal. Don't give percentage fill horizontal. It is location horizontal. Click that and here give the tag name. S2 I have given. So left side is your slider limit, right side is your movement limit. Now see here, if you go to runtime, see the object is moving in this line, but it is not moving completely here. No, so what I didn't do means I didn't give the exact distance here. So how will you give the exact distance means here at the bottom, if you see, there are two options showing here, X and Y. X, Y it is showing. X means it is showing one value. Y, for that it is showing one value. So if I just keep the cursor here, it is horizontal movement only. So I have to take X value. For vertical movement, I have to take Y value. I'm just keeping the cursor. Wherever I keep the cursor, see it is changing. Now it is 550, 450. But if I go inside this, see, according to the place where I keep the cursor, the value is changing here. So just keep the cursor here. For X, it is showing 150. I want to move the object till this distance. So here it is 150 and here it is some 650. 150 to 650 means I have to take that difference. 150, 650. So 650 minus 150. What is the total distance means? It is around 500. So what I have to do? Double click this object. Go to horizontal, and here towards right it is showing 100. So only it was moving till 100 here. Now if I change this to 500, so see what is happening. If I go to runtime, the object is moving in this till that distance. So like this you can move the same object either horizontally or vertically also. So like this only you will be designing this simple designs and all. Now for example, I am deleting this. I have one tank here. Next I am taking two tanks. So first this tank should be filled. After that only this tank should be filled. But I have slider limit as 0 to 100 only. So what I have to do, I have to split the slider limit into two halves. So for first tank, I am giving 0 to 50. So this tank should be filled in slider range 0 to 50, and for 50 to 100, this tank should be increased. So see here, double click this. Percentage fill vertical, I am giving 0. Here I am giving 50. 0 to 50, 0 to 100 I am giving. Tank level 0 to 100, it should be completely filled. So 0 to 50 is the slider limit. Left side is slider limit. I have given like that. Now here for this object, what I am going to do, double click this. Same vertical, I am going to give minimum as 50, maximum as 100. So 50 to 100, it is going to fill 0 to 100. So input slider limit, if I give 0 to 50, first object will be filled. Second object 50 to 100 only it will start. So see here, if I go to runtime, if I increase this, see first this tank is getting filled from 0 to 50. After 50, this tank starts getting filled. So since I have not disabled this, still that is also moving. So if I double click this object, if I disable this property, that will stop moving. And see here, this is filled and then this is filled. So like this, you can split the slider also. Now I am deleting that tank. I deleted all these things. I am having this slider. First, I am moving this object horizontally. Next, using the same object, I am going to move this vertically like this. First horizontal, then vertical. So what I have to do, first you have to, again here also you have to change the you have to double click this object and you have to change this object and give the horizontal location from 0 to 50. So what will happen, 0 to 50 it should move horizontally and 50 to 100 it should move vertically. So here I have given, if I increase the slider from 0 to 50, it will come here. From 50 to 100, what will happen? It should move vertically, right? So for vertical, same object I am double clicking, vertical I am giving 50 to 100. I have to give the tag name here and I have to give the vertical movement also. So I have to measure both the distance here. Keep the cursor here. Here it is 200 and till this distance it should move means it is 740. So the total distance 740 minus 200 means it is around 540. So double click this, go to horizontal, give 540 here. So 0 to 50 it will move from 0 to 540. Next, same object, keep the cursor here. It is 130. See here at the bottom, here only you have to see. Keep the cursor here, it is showing 130. Till this distance it should move means 420. So 420 minus 130, it is around some 290. Okay, so double click this, go to vertical and give 290 here. So if you give 290, see what is happening. If I click this runtime, first if I move, it is moving horizontally. Next it is moving vertically. Can you see? Same object, first it was moving horizontally, now it is moving vertically. So this is how you will create animations for these designs and all. Now I'll show you what are all the other types of animations which can be given. Now if you double click this, see you have one option called object size. So when this object size will be used means, just assume I have a conveyor like this. So I have a conveyor like this, and this conveyor is facing towards me. Okay. So the object has to be moved in this conveyor. The size of the object is like this. Now this object has to be moved in the conveyor vertically. Now what I am going to do, I am going to double click this. I am going to give vertical property. I am giving 0 to 100. It should move in this. So see here, if I give vertical property, object is moving like this. But what is happening? It is a conveyor which is far away from us. So if I stand here and see, initially the size will be very small. If it is coming nearer only, the size will be varying. So for that, I can vary the height and width of the object. So height also I am going to give, and width also I am going to give tag name. So now if you see how it is. I have given vertical movement as well as height and width also I have given. So size of the object, see initially it is smaller. When it is coming nearer, automatically the size will be increased. When it is going back also, see, if it is nearer to you, the size, exact size it will show. But if it is going far away from you, see, the size is small. So like this only the designs has to be made by giving all these types of animations. So percentage fill means it is used for filling, tank level filling, like that. Location means it is used for moving the object. Object size, it is used for varying the size of the object. Next, you have one option. See, you have an option called visibility here. Miscellaneous visibility. So what is the use of visibility means? If you click this visibility, here I'm giving S2, that tag name. I'm giving greater than 70. S2 greater than 70, I have given this property. So what will happen automatically till 70, see, you cannot see the object. Till 70, you cannot see the object, but if it is more than 70, then only object is visible. So what you can do, you can hide the object also like this. Till 70, it should be hidden. After 70 only, it should be showing like that. So you can give any limit. Here I have given 70, but you can give any limit. Like for example, I am giving S2 greater than 20 space and S2 less than 60. So greater than 20, less than 60 means 20 to 60 only it will be visible. See, initially it is not visible. After 20 it is visible. 20 to 60 it is visible. After 60 again it is hidden. So like this you can give visibility property and all. So where and all you will give this visibility property? At which case it will be used means, for example, see, I have an object that has to be moved in a conveyor. Just assume this is one object. Just for understanding purpose, I am doing like this. I am having this object. This object has to be moved in this line. First, this object will be moved horizontally, then vertically. After vertical, again it has to move here. So in this place, like this here only, the object should be moving. Okay. So now what I'm going to do is I'm going to measure the distance. So first it is horizontal, next vertical, again horizontal. So I have to divide the slider range into three different parts. So for example, 0 to 30, it should move like this. 30 to 70, it should move vertically. Again, 70 to 100, it should move horizontally. So what I'm going to do is, first double click this, go to horizontal. Before that, measure the distance. Keep the cursor here. It is showing axis, it is showing 150. Here you have to see. It is showing 150. Till this distance it should move means it is 390. So 390 minus 150. What is the total distance means? You can calculate like initially it is 150. Here it is 390. Okay. So double click this, go to horizontal. I'm giving left side slider limit 0 to 30. It should move 240. 390 minus 150, it is 240. I have given 240. So first I will check that. See, sorry, visibility property is enabled. So I'm disabling that visibility. First this object is moving. Till this it is standing. Now it should move vertically like this. So measure the distance from here 160 till this distance 360. So 160, 360 means it is 200. So I'm giving vertical 30 to 70. So 30 to 70, it should move 0 to 200. So now see, it is moving like this. Next, it is moving like this. Again, it should move horizontally like this. But can you see here? Already I have given horizontal property for this object. Again, I cannot give horizontal here. So what I have to do, you have to just right click, create a duplicate. Right click, create duplicate and paste that object here. So this is nothing but the duplicate of this object. Now that After this move object has stopped here, this duplicate will be moving. So double click this. It should not move vertically, only horizontally. So horizontal 70 to 100 it should move. I have to measure the distance. I keep the cursor here, it is showing 390, 390, 690. So 300 I am giving. Now see here, if I go to runtime, first this object has moved and stopped there. Next this object has started moving. But during the runtime, I should show only one object. The same object is only moving like that. I should show. So animations and all they will do like that only. So what I have to do? Just to double click here. Go to visibility. So here horizontal I have given 0 to 30, vertical I have given 30 to 70. So visibility I am giving S2 less than 70. So S2 less than 70 means what it will happen means till 70 only. Less than 70 means 0 to 70. Till 70 only this object will be visible. See, after 70 that object got invisible. And this object should be visible after 70 only. So what I can do? Just double click here. Same visibility. Now I can give greater than 70. So see here. So it is displaying like only one object is moving here. So this is how they will use these visibility property and create those animations and all. Okay. So now what I am going to do, same like this, I am going to add another step here. So with the same object, what I am going to do is I am going to create animation and I am going to move this object. Now this object first it is coming here, stopping here. Next this object stopped here. It should again move top. So I have totally 1, 2, 3, 4, 5. Totally 5 distances are there. So what I have to do? First double click this. Give horizontal 0 to 20. Next for vertical I am giving 20 to 40. So after this, again for this object I am giving horizontal 40 to 60. I have to measure the exact distance. Keep the cursor here 360 till this distance means it is horizontal. So 390 till this distance means it is okay 200. So for this object 300 it should be given. Next the same object should move in up direction. So from here till here. So 360 it is 130. So 200 for this I have to give, but it should be going in up direction, bottom to top. So what I have to do here, bottom I have to give 60, top I have to give 80, and bottom I have to give 0, top I have to give 200, because it should move in the reverse direction. So bottom should be less and top should be more. So now see here. I'm disabling this visibility. I'm going to give when this object should be visible from here to here. So till 40. So here I'm going to give S2 less than 40. Next, for this object, I'm going to give S2 greater than 40 space and S2 less than 80, because till 80 this should be moving. So see here, first this object is moving, next this object is moving, and after that that object is invisible. So what I am going to do, I am going to place another duplicate for this. Right click, create duplicate, keep that object here, and for this visibility I am going to give greater than 80. S2 greater than 80, and this should be horizontal movement, 80 to 100. So that distance exactly you have to give, measure that and give. Now see here, only one object is there, but in design I have 3 objects. So see here, if I vary it, it is showing like only one object is moving. So this is how you have to create the design. So like this only animations and all will be created. So visibility, next you have blink property. What is blink means? Here also I can give S2 greater than 70. So for alarm and all you can give blink, or for on off condition you can give blink. See, after 70, till 70 nothing is happening, after 70 it starts blinking. So like this blink property can be used. After that you have orientation, rotation property and all I have. So double click this, give orientation. I'm giving the tag name. Now see here, this object is rotating. So if you want to show rotation and all for any objects, for fan or something like that object, you can give this orientation, rotation property. So you have many properties like this. Next, you have one more property. For example, just assume this is my tank. I can create tank from simple factory, or I can use this tank. Vertical filling I am giving for this. So what is happening? This is getting filled. Now I want to see the level of the tank. Okay, I want to see the level of the tank. So for that, what I have to do is, at the right side of the screen, if you see, there is an option called text. There is an option called text here. Click that text, click here and type hash. Click text and type hash here. After typing hash, double click this, you can see one option called value display. So there is an option here called value display. So in value display, tank is analog. So click analog here and give the tag name S2. So after giving that, see, if you go to runtime, initially it is showing 0. Based on the level of the tank, automatically it is showing the level also there. So like this, for on-off conditions also you can give. For example, I'm going to use this as my lamp. So double click this. You are having one option here called fill color. Fill color discrete. Discrete means digital. I'm giving this one. For on, one color I'm going to give. For off, I'm giving one color. So I'm going to give one input for that. Switch I'm taking. So this is the input for that. Now see here, on, so it is showing like this. If it is off, it is showing in this color. So like this, for on off color you can give. Same way for tank level filling color also you can change. See, fill color, analog. So I have to give different values here. I'm giving 0. So for every level I can give different values. Or you can give normal color for everything. Only for critical level you can give red color. So for low level I am giving this color, and when it reaches high level again red color. Low level and high level it should be in red color. Normally it should be filling in green color. Now see, it is showing red in color. After that, if it is crossed, it is showing green color. Again, if it is reaching peak level, it is showing red color. Like that, I can give different colors for filling also. So this is how, what we can do is we can give filling colors and all for this. Now, for example, I have one object. So this is my object. I'm going to use this as my switch. So just I am typing a name. Using text, I am typing a name as switch. Instead of using a real-time switch, I am creating my own switch. So using this, I am going to give the input for this. So I am deleting this. Double click this object. Here you have one option called touch push button discrete value. So touch push button discrete value, if I enable that, see, I'm giving S1 as the tag name. Now see what is happening. This is off. If I click this, it is on. If I again click this, see, it is off. On and off using this object. If I click this, it is on and off like that. So you can take either the predefined design or you can create your own design also. Now, this is my input. Same, using this object itself, I want to create the input. So see here, user input, one option is there. Select this discrete value. Here I am giving S1. Now what will happen is, this is off now. By clicking this, if I turn it on, it will be on. By clicking this, if I turn it off, it is off. So see what is happening. It is on and off by using the same design. Okay. So next, if you see here, analog. One analog option is there. Analog can be used for this one. Now what is happening? This, using this, you are going to display the value. But you cannot click this and do anything. It is just displaying the value. But what you can do, same thing, instead of giving value display analog, if you give user input analog, so what will happen means, it will display the value as well as if you click this and give some value here, 80. So it is reaching 80. If you give 0, it is reaching 0. So using this object, you can create the inputs also. So same object can be used for creating input as well as displaying that using user input. But if you give value display, it will only display the values. So these are the different types of animations that can be given. Now I have one window here. I'm creating another window, file, new, window 2, like this I'm having. So totally 2 windows are there. I'm having many designs here also in this window. If you go to runtime, see only one window is visible at a time. So what I can do, I can switch between different windows. Again, I have to go to file, open window, create another window, click another window, give OK, then it will be visible. If you want to go to the other window, go to File, Open, Window 2, then only it will be visible. But instead of doing like this, what I can do, just I can click one option so that the next window will be visible. I'm keeping, see here. So if I click this, here I'm going to type window 1. If I click this, window 1 should get open. So double click this. You have an option called a show window. So click that show window, select window 1. So what will happen? If you click this window, this button, automatically window 1 will get open. Now in window 1, I'm going to do the same thing. Create one design here. I'm just typing window 2. So double click this, click show window, I'm clicking window 2. Now if you select runtime, see what is happening. Now this window is visible. After completing all these things here, if I click this, it is going to window 1. Now after completion of all these process here, if I want to see window 2, I can click this, it will go to window 2 like that. Like this, I can have multiple windows and I can switch between different windows. So these are the different animations that can be given in SCADA. So I will design different process and I will show you all these things, how to use these in different real-time process and all. Okay. So till this, it is enough for this session. So we will see the remaining things in the next session.
Sir, just tell, inform the time, sir, please. 11:30, sir.
Yeah, okay. So next session will start at 11:30. At 11:30 sharply, we'll start the remaining topics. Yes, friends. So we will start the session now. So as we have already discussed, we have seen how to create animations in SCADA like that. We have seen what are all the different animations which can be given. So all those things we have seen now. So now we will see what are all the different applications we can do in SCADA. Application in the sense we have seen data collection, right? So how the data can be collected, what are all the different formats in which we can collect the data, like that. We can see different conditions now. So the first thing what we are going to discuss now is trends. So what is trends? Trends are nothing but graphical representation of field parameters. Graphical representation of field parameters. So field parameters in the sense, for example, you have tank level, you have pressure, temperature, speed, like that. Different field parameters will be available in the process. So all those field parameters can be monitored in the form of graphs. So normally you are getting a value in a form of number. For example, speed 1500 RPM, 2000 RPM, 3000 RPM, like that you are getting. Tank level means you are getting in the form of 30%, 50%, like that. Temperature, pressure, all those things you will be getting in a form of reading. So with that reading, we cannot compare that with the previous process. You will have only the values. But mainly for comparison, what we can do is, if you have multiple processes like this, all those processes can be monitored in the form of a single graph. So with that graph, what we are going to do is we are going to monitor all those things. So that graphs is only called as trends in SCADA. So in trends, we have two types. One is real-time trend, and the other one is historical trend. One is real-time trend and the other one is historical trend. Real-time trend in the sense, if you have a process which is happening now, at present, what process is available, that process can be monitored in the form of graph. For example, if the process has passed some half an hour or 1 hour back and all, that process, if you want to see, you cannot see that in real-time trend. It will show only the present status of the process. Currently, what is the status of the process? Currently, what is the level? Currently, what is the temperature, like that? So in real-time trend, we can monitor only the present status of the process. In case if you are having historical trend, what we can do, we can even monitor the past status. Past status in the sense, even some 1 month earlier process or 2 months earlier process. So that process, you can compare that with today's process, and you can do some modifications or any changes like that. So this is the use of trends. So mainly for comparison and modification only, they will see the process in a graphical representation. So here I have mentioned field parameters. Field parameters are nothing but level, speed, temperature, pressure, flow, like this. So all these status you will be monitoring in the form of graph. So now we will see how to design this process in SCADA and how to monitor the process in a graphical format. Now just assume I have a slider. This is giving the input for this tank. So I'm going to take a tank. So tank will be available under Wizards, Symbol Factory. From this, I'm going to take a tank. So I have taken a tank here. So this tank status only I want to monitor in the form of a graph. So for that you need a graph now. So where that graph will be available means same Wizards. Here you have trends. So select trends and choose the option 16 pen trend. Select trends and choose 16 pen trend. So after selecting that 16 pen trend, if you give OK and click here, that graph will be appearing. So in that graph, in one axis you will be having time. In one axis you will be having time, and in the other axis you will be having the field process. Either it can be level, temperature, pressure, like that. So always one axis will be time only. So the graph can be monitored. Graph can be used for monitoring the process with respect to time. That is always x-axis will be time only. Now we have to configure the level for this graph now. So how to configure it means just double click this. Here it is asking for tag name. So in this only you have to give the tag name. So if you double click this and scroll here, it is showing the tag name which is available. So select the tag name, give OK. So here, if you see, there are different divisions: time axis format, value axis format. So time axis in the sense, major divisions, minor divisions are there. It is 5 cross 2. So 5 cross 2 means totally 10 divisions will be available here. If you want to increase that also, you can increase. For example, if I change it as 10 cross 2, this division will be 20. Now here value axis means y-axis. So this y-axis totally we have 20. So 10 cross 2, 20. That also if you want to change, you can change. So according to the requirement, you can change this. And background color, that is the chart graph color, also you can change background color and border color. Next, here it is showing the update rate. Update rate, it is showing 2 seconds. So what will happen, for every 2 seconds the graph will be getting updated. Okay, if you want to change for every 1 second it should be updated, means I'm changing it as 1. total span of the graph is 60 seconds. So it will show only the present 60 seconds process. So here I have selected real time. So what will happen? It will show only the current status of the process. So after doing all these changes, if you select done, what will happen is, see, it is getting modified according to the change what we have did. So after this, if I select runtime, so see what is happening here. If you increase the level of the tank, according to the increase and decrease what you have in the process, the graph will be getting updated here. Okay, so this is monitoring the process with the help of graph, that is trends. Now I said the total span will be 60 seconds. So in case after 1 minute, if you see, you cannot see this process. It will show only the current process. So what you can do, you can see that in historical trends. So how to configure that historical trend, that we will see now. Real time means it will show only the current status. Historical trend means if you want, you can save that past status, retrieve it currently and see that condition also now. So how to do that means, for that we have to do some configurations. So first you have to close the runtime window. Runtime window, it will be minimized at the bottom. You have to close it. Then only what will happen, the configuration, whatever you do now will get saved. So first what you have to do, double click this process. There is tag name here. Double click that tag name. After double clicking the tag name, here there is an option available called log data. So what you have to do here means you have to enable this log data. So enable log data, select save and close. If you enable log data only, what will happen is the process will be getting stored. That is the data's value. You have enabled log data. So the data will be getting logged or stored. So after doing this configuration, select special, configure and choose historical logging. Special, configure historical logging. After selecting special, configure historical logging, here there is an option, enable historical logging. So what you have to do is enable historical logging and give OK. So after enabling that, now what you can do, you can directly go to runtime. Now this graph, it is showing the current status. So this modification was happened at 11:43:59. Okay, 11:43:59. This process changes was happened. Now just assume I am allowing it to pass. So after 1 minute, what I can do, I can retrieve that and see according to the requirement also. So now I have used only real time trend. So what I have to do for historical means just click that graph, change it as historical, just give the time at which the process occurred. For example, I am giving 4:43:58 to 4:44:58. That process I want to monitor. So if you give done, see what is happening. It is showing that change which was happened. Now again, if you want to zoom in, you can give that exact time also, like 4:43:50 till 4:43:60. 10 seconds process I want to monitor. So you can give the start time and end time. Now if you give done, so see here again, it is showing the same status. Now again, if you change it to real time, what will happen? It will show what is the current status. If there is any modification, that also it will show. So it is showing now 11:46 process you are seeing. This times process you are seeing. But if you click this, change it as historical and give that time. For example, I want to monitor 11:40 process means you can change that time, and if you give done, it will show that process. So this is only real time and historical trends. So here I have shown you example with only one tank, but what you can do, you can define multiple process. Like here, since it is simulation mode, I am just showing you with the tank, but you can configure that for level, temperature, pressure, like that different process, and all those process tag name you have to give it here. Then you can monitor all the process together in a single graph, and you can compare where is the difference, which process is changing, like that. So this is about trends. So the next topic what we are going to see is alarm. So generally, what is the use of alarm means? To indicate some status, okay? To indicate the condition only, we will be using alarm. Now, after getting the indication, what you will do, you have to take some corrective measures or preventive measures. So this conditions, I said, no, this can be any abnormal condition, or it can be any normal condition, or it can be any critical condition, like this. Different types of conditions can be monitored in the form of graph. Sorry, previously we have monitored in the form of graph, but in alarm we can monitor that also. So how it can be done? We will see that with an example. What are all the different types of alarms that can be given for a process? So generally, just assume this is a tank. Okay, I have a tank here. So normally for a tank level, what are all the different kinds of alarms we can give? Means either it can be low level alarm and high level alarm. So we have low level alarm and high level alarm. Low level alarm means what will happen if tank level reaches this level. For example, I am keeping low level alarm at 25%. If tank level reaches 25%, low level alarm will be activated. If tank level, for example, I am giving 75% for high level. Tank level reaches this level, what will happen? High level alarm will be getting activated. Now, just assume normally with this low level and high level alarm, we can control the process. If there is any alarm, we will take the preventive measures. Just assume in case for critical process and all, what will happen? They will be having some additional alarm also, which is called as high level alarm. High level alarm. And same way for low also, low level alarm. So what they will do is they will give, for example, high level at 90%. Sorry, high level they are giving 75, no? So high they will give it as 90%. Low level they will give it at 10%, like that. So different conditions they will be giving here. So what will happen? Even if it is reaching low level, you are not taking any preventive measures also. Again, there will be another alarm it will show low alarm, level alarm. So it is much critical. So you have to take the corrective measures immediately, like that. So like this, different conditions of alarms we can give. So this can be done for many other process also, like speed. Speed we can give 1500 your target. If it is more than 1500, high level, it is running at very abnormal condition. If it is low, it is low level, like that. For temperature, pressure, everything, you can give alarm conditions. Okay. So how to give that means, normally same way for this tank only I have to give means, just double click the slider, double click the slider, double click this tag name, double click slider, double click the tag name. After that, here you have an option called details and alarms. So select details and alarms. After selecting details and alarms, here it is asking low, 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 high, 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 like that. So you can just enable that. If it is required, you can enable, give the value. If it is not required, just disable it. I'm enabling low, low. I'm giving 10% for that. For low, I'm giving 30. For high, I'm giving 70. For high, I'm giving 90. So after giving all these things, you can just select save, close. Now for monitoring the alarm, go to wizards, select runtime tools. You have runtime tools here. In that, I'm selecting alarm point monitor. So click alarm point monitor, and if you click here, in this only it will show the alarm point. Now you can directly go to runtime and see here, according to the variation, it will show the alarm here. How it will show means, here there is an option called name. No, just click the name and give the tag name for the process. After giving the tag name, now what is the tank level? It is 0. So there is some alarm. That is low, low. Why low, low? Because the tank level is less than 10%. Okay. So now, based on the increase in the level, according to that, the alarm will get changed. Now there is no alarm because it has crossed that 30. When it reaches 70 only, high level alarm will be there. See, high level, high level, like that. Now alarm is stopped at normal condition. For critical condition, it will show the alarm. At that time, what we have to do, if we are sitting in front of the SCADA PC, we will receive that alarm. According to that, we can take the preventive measures for the process. Okay. So that's all about alarm. This is how you will be using alarm for the process. So next we have another application called DDE. DDE stands for Dynamic Data Exchange. DDE stands for Dynamic Data Exchange. So using this, what we are going to do is, we are going to exchange the data which is available in SCADA to MS Excel. So I'm having MS Excel here. So from SCADA, what we are going to do is, we are going to exchange the value to MS Excel. And from MS Excel, again, that data can be transferred to SCADA. So how it can be done, how these both are communicated means, this both are communicated with the help of this DDE protocol. So DDE is acting as a protocol to communicate SCADA and MS Excel. So how it will be done? That procedure I will be explaining you now. So first, what we have to do, we have to design which process we are going to exchange to SCADA. That process I have to design first. So exchange in SCADA, that process we have to design first. So for this, I am giving the tag name as S1. This is on-off process. For this, already I have given S2. Now this process only I have to exchange in SCADA. Sorry, exchange from SCADA to Excel. So what I am going to do is I am opening Excel sheet. After opening Excel sheet, click the option New, File New, open a new Excel sheet. For example, I want to exchange the data in this column. Switch data I need in this, lamp data I need in this, slider data I need in this, and tank data I need in this. So same tag name only I have given. So I'm just taking one tag name. S1 process I need in this, S2 process I need in this. Just for example, here I'm giving lamp, and here I'm giving level. So under lamp, it should show the lamp status. Under level, it should show the tank level. So here, go to File, select Save As, and selecting desktop. So in this place, I am going to store the values. So I'm just giving a file name for it. I'm just giving the file name as data. So after that, just check it is in desktop and what is the file format. So the format of the file it is showing here. It is stored in C directory desktop data.xlsx. It is showing xlsx data.xlsx. So this xlsx you should not forget. So what I am going to do after designing that, double click the slider, double click the tag name, here there is an option type. So select the type and change it as IO real. Previously it was in memory real, but now you have to change the data type as IO real. IO real in the sense then only the data can be exchanged with another application. So here SCADA is one application. The other application what you are going to use is Excel. So after doing that, here there is an option called access name. So click on this access name and choose add. Click access name and choose add. After that, here it is asking for access. So you can give any name here. So just I am giving PLC. So just to give any name here. No need of giving anything in node name, just give application name. So as I said earlier, which application, which third-party application we are using now to exchange the data? It is MS Excel, right? So you have to type it as EXCEL, Excel. So after giving the application name, next it is asking for topic name. Topic name is nothing but the file name what we have given for that particular Excel. It is data.xlsx. So give that file format also. Data.xlsx. So after that it is asking which protocol to use. Okay. So select the option DDE. So select DDE and give OK. Select DDE, give OK and select the option close. So now here what you have to do, for example, this is for S2, that is level. So where I have to store the level, I have to store the level in this column. This particular cell only I have to use. So for this cell, one representation is there. It is row number 2 and column number 2. B means it is 2. Row number 2, column number 2. So how we have to give means you have to give it as R2C2. R2C2 means row 2, column 2. Then only what will happen, this particular data will be shown in that particular cell. Now do the same for switch also. So double click the tag name, change it as IO. Select the already defined access name, because in this already we have defined the Excel data.xlsx, the file name, everything we have defined. Now here this data should be stored in row 2, column 1. So R2C1, like this you have to give. After that, select save, close. So now if you go to runtime, so see what is happening. So here that file is available. I'm opening that file. In order to view both the things, I'm minimizing it and I'm keeping like this. Now if you vary the level of the tank, can you see the data is exchanged here? So based on the increase in the level, the data from SCADA is exchanged to Excel. Now from here, the data is transferred here to Excel. Now if I click this and if I give 45, see, from here the data can be transferred to SCADA also. So both way you can do, like transferring as well as receiving. And here, turning it on, and turning it on, this is on and off. So based on that, it is showing the value here. If I give 0, see, it is off here. If I give 1, it is on. Like this, based on the changes which is occurring here, you can exchange the data from Excel to SCADA. So this is done with the help of DDE protocol. So these are the different applications which are available in SCADA for data collection. We have some more application, we will see that later. So now I will show you an example, a real-time example, and for that how to design the process and give animations. Okay. Now what process I am going to take means I am going to take bottle filling process. So I'm just naming it here. Bottle filling process, like that I have named it. Now I am going to take a conveyor. So where conveyor will be available means it will be available in conveyors miscellaneous. So from this I am taking a conveyor. It is available here. Next I am going to take sensors. I am taking a sensor. Next, I am going to take a filling machine. For filling, I am taking one. So using this only, I'm going to fill the bottle. Next for capping, I'm taking another. So this will be keeping a cap on the bottle. So for bottle, I'm taking containers. From containers, I'm taking a bottle. So what should happen here means, when I increase the slider, automatically this sensor should be on if the bottle is directly in contact with this. After that, object should be moving. This object should come down, it should fill the bottle, go back. Same way, this object should come down, it should keep a cap on the bottle and go back. So for that, we have to give some animations. So I'm going to give the tag name as S2 for this. Same tag name only I'm going to give everywhere. So for initially the bottle is available here. Sensor is available here. I'm giving text here. It will show the slider limit. See, if I increase it, it is showing the slider limit. According to that, I'm going to configure all these other things. So this sensor should be blinking when the object comes here. So when the object comes here, sensor should be blinking. So I'm just going to give some animation for that sensor. So I'm going to give blink option for that. I'm going to give S2 greater than 5 and S2 less than 10. This is nothing but the limit, because I have the total limit is 0 to 100 using the slider. Using the slider, the total limit for this process is 0 to 100. So when the object reaches here, it will be around 10. So here 10, 20, 30, 40, 50 like that it will be approximately, I'm saying. So if it reaches 10, this place will be nearly 5, no? So only I'm giving here 5 to 10 it should be blinking. So see here, it starts blinking. So same as that, less than 5 it has stopped. When it reaches 5 to 10 it is blinking. So object has to be moved and it should be stopped at this place, right? So I have to measure the location for this. It is x-axis movement. So at the bottom it is showing x and y-axis. Just keep the cursor here. It is showing x-axis. It is showing 260. And till this place it should move means it is 590. So 590 minus 260. What is the difference? It is nearly So I think it is around 240, nearly 240. Just see here, if I give 0 to 100, what will happen? Completely the slider will complete here. See, it is stopping here itself. So exact distance I am going to give. So I'm going to give 320. Okay, so I'm giving 330 here. Okay, so if you give 330, what is happening? Object has moved and it is straight with this. But after this, I cannot use the slider. No, so what you have to do, you have to divide the slider for each and every conditions. Now, what I'm going to do, from 0 to 20 itself, object should go and stop there. So I'm giving 0 to 25, just for example. So when I move it like this, see, if it is here, sensor is blinking. Next, if I vary and till 25, what is happening? It is moving and it has stopped here. So after it has stopped here, what should happen? This object should come down. So that object should come down, right? So for that, I have to give movement property. So here, this is horizontal movement. So this object should be given vertical movement. So I'm giving vertical. Which position I have to give? Because already 0 to 25 that object has completed. So I'm going to give 25 to 35. So 25 to 35, that object should come down. So simply I'm giving 50 in order to check the level. Yes, it is perfect. So I'm giving, see, first this object has moved, it has stopped there. After that, that object is coming down. Till 35, it has reached down. Now what should happen? Bottle should start filling, right? So for filling, I have to again give fill property for this bottle. So double click, percentage fill, vertical. So here, when this bottle should start filling, after that object reaches down. That is, I have given 35 for that. So I am giving 35 to 45. This bottle should be filled. So for this, I have given 0 to 25. For this, I have given 25 to 35. It should come down. Again, for the same bottle filling, I have given 35 to 45. Now see, initially bottle is empty. Sensor is sensing. Object stopped there. That object comes down. After it reaches down, bottle is done. Bottle is filling. Okay, bottle has filled and it has stopped. Now what should happen? This object should go back again. So this object should go back means again for that I cannot give vertical because already I have given vertical property for the same object. So what I have to do? I have to right click, select duplicate and keep another object here, and this object should go back. First this object came down, then this object should go back, and I have to give visibility property. Visibility property means this object should be invisible after this is visible, like that. So here I am going to give, for this object I am going to give vertical bottom to top. So 45 to 55, this object should move 0 to 50. Now see here, if I go to runtime, first that object is coming down, it has stopped there, filled, and this object is going back now. But in the real time, you have to show like it is the same object. Okay, so what I have to do there means you have to give visibility property. First, this object should be visible. So till which limit it should be visible? I have given 35. No, so till 35 that object should be visible. So S2 less than 35, this object should be visible. Now this object after 35 it should be visible. So S2 greater than 35. Now see here during runtime, it is showing only one object. It is showing only one object. First that object comes down, it is getting filled. After it is filled, next this object goes back. It is showing like only one object is doing that function, but I have two objects there and I have used visibility. So this is how you have to do animations here. Now do the same for next object also, but here object has stopped here, no? After filling it has stopped here. Again, the same object has to move here, but the same object cannot be moved there. So what I have to do, I have to use another object here. I'm keeping this object. Now this object should start moving till this position. When it should start moving, after this object reaches the top position. So 55 it is reaching, no? So I'm going to give horizontal 55 to 75. This object should start moving. So I have to measure the distance. It is 590 till this distance meant it is 950. So it is nearly around 360. So see what is happening if I go to runtime. First this object has filled, next that object has to be moved and it has stopped there, no? So this for the first object you should give visibility property. So till 55 that object should be visible. After 55 this object should be visible. So like that I have given. Now see if I go to runtime and if I activate it. So this object has stopped here at 75, it has stopped. Now this object should come down. So this object should come down same like this. So for this what I can give? Again movement property, vertical direction from 75 to 85, this should come down. I am taking another object here. I'm keeping that object here. This object from 85 to 100 or 95, this should be. So I'm going to keep cap. Just assume this is the cap. So this cap should be placed there. So cap should be visible after 95 like that. And so see here, it's getting filled. After it is getting filled, come down. It has left a cap there. So exact distance and all, if you measure, it will be proper. So now for this also visibility property I have to give. This should be visible till 85. So slider, sorry, S2 less than 85, this object should be visible. Greater than 85, this object should be visible. You see here initially every object is single object now. It's coming down, filling the bottle, it is going back. After it has reached there, this object starts moving. Next, this is coming down, placing a cap there. Okay, so this is how animation should be done for the process and all. So here I have explained the bottle filling process. Next, I am going to design another process for tank level filling. So I'm taking a pump here. So from this pump, some liquid should fill this tank. Now from here, just assume I'm having a valve here. So all the designs, whichever I'm taking, it is available in Simple Factory itself. So just assume from here it is going to some their cooling section or heating section, like that. It is going to some other section. So for this, again, I have to create animation. Okay. So for that, how do you create that animation and all means? Here, first, all these things should be happening when I vary the slider. So I'm giving S2 for this. So first, initially, pump should be on. So pump on and off, I'm giving two colors. So fill color, discrete, I'm giving. Or you can give blink property itself. In blink itself, I'm giving S2. till some level it should be blinking, or just I'm giving S2, what will happen? When it is 0, nothing will happen. If it increases, it starts blinking. Now, here I'm going to give filling property for this. For this pipe, I'm going to give filling property. Horizontal filling, I'm going to give S2. I'm giving 0 to 20. This should be filling. See, it will be filling like this. So for pump also you can give filling property. Vertical filling. So see here, pump level is also getting increased. This is also increased. Now valve also I can give blink. So when valve should be open means I can give like S2 greater than 10. So if it is greater than 10, when tank level is greater than 10, that should start blinking. That is, water level reaches here, valve is open. After valve is open, this tank should be increased. So for that also you can give the property line. Vertical filling from 20 to, you can give from 20 to 60, this should be filling. So initially what is happening? Everything is off. Pump has started. Tank level is getting increased. After that, here also I can give filling property. So I have given till 50, this should be filling. Till 60, this should be filling. So here I can give 60 to 65, this should be filling. 65 to 75, this should be filling. This should also blink if it is greater than 70. So like this, for everything you can give animation like this. So initially tank level is getting increased, valve is open, next this is increased. After it reaches that level, this is full. Now we can give some indications also for this low level, high level indication. Now means by using sensors. Go to symbol factory, select sensor. I'm going to keep two sensors here. So this is low level sensor and this is high level sensor. Low level sensor I'm going to use AS2. If tank level is less than some limit, like if tank level is less than 30, till 30, this should be blinking. And here if tank level is greater than, for example, I'm giving greater than 50, this should be blinking. Just according to our requirement, we can give it. So initially tank level is 0, so this is blinking. So if it is increased, see after it has crossed that level, it is stopped. Will be stopped. Now if tank level reaches higher level, that indication is happening. So like this only you will be giving animations. Okay. So now we will see another topic called script. So till now what I have did was for input and input as well as output, I used the same tag name only. S2 here, and for all the things I have given S2 only. But in case if you are using multiple tag names, so how to design the process? So that is what we are going to see now. So the topic which you are going to see now is script. For example, first we will see with digital conditions, that is on-off conditions. Just assume I have a lamp and I have a switch. So here I am giving SW for switch, and for lamp I am giving LAMP like this. So for writing script, script is nothing but programming language used in SCADA. Okay, it is just a programming language used in SCADA. For writing the script, we have to follow some syntax. So what is the syntax means? Just consider this is your input. Switch is the input and this lamp is the output. So this is nothing but the tag name of input, and this is the tag name of output. Now what is the syntax for this means? Here normally what should happen? If you give different tag name, if input is on, output will not be activated. I can show you an example also. See, I'm having a switch. I'm having a lamp and I'm going to take a switch here. So I'm giving SW for this, and for this I'm going to give it as lamp. Now see what is happening. I have given SW for this, and for this I am giving lamp. Now if you go to runtime, if the input is on, there is no change in the output. If input is off, what is happening? There is also no change. For on and off, nothing is happening. But now in case I am giving S1 for this, same S1 for this. Now see what is happening. If input is on, output is activated. If input is off, output is deactivated. In case if you are giving same tag name only, what will happen? The process will be functioning. But now I'm going to use different tag name. I'm giving SW and lamp. So I said for that there is a syntax. And what is that syntax means? You have to type like this. First you have to start. I'm saying now, if switch is on, then lamp should be on. That is only the syntax. If you have to start with if SW switch is nothing but the input. If input condition is getting satisfied, then what should happen to the output? So output will be called as statement. Here you are starting that if, no, so same way you are going to end that if. For output, you have to use semicolon, and for end if also semicolon. So this is the syntax. So how you have to write the script for this condition now means just follow the syntax. If for SW is the tag name for input. So SW is on. How you will mention that on condition means equal to 1. Okay. If SW equal to 1, then lamp equal to 1. For input only you have to use double equal. For output single equal only. So here semicolon, next is end if semicolon. If SW equal to 1, then lamp equal to 1, end if. So I have to write this script. Where you have to write this script means just right click in this empty space. There is an option called Windows script here. After designing, after giving the tag name, right click in the empty space, select the option Windows script, and here you have to type if SW equal to 1, then lamp equal to 1, semicolon, end if. So after giving this, here there is an option called every 0 millisecond. So it is nothing but the scan time. So it should not be 0. Other than 0, you can give any value. For example, just assume I'm giving 1 millisecond. Okay. So 1 millisecond is very fast, right? So I'm giving 1 millisecond. So what will happen if switch is on? Immediately lamp will be on. So after writing this, give the time delay here. After that, give validate and give OK. If you give validate, if there is any error, it will show. For example, I have missed this semicolon here. If I give validate, it will show expecting semicolon like that. So validate, OK. Now if you go to runtime, see, switch is on, lamp got activated. Now, in case I'm turning off the switch, see, nothing is happening. If switch is on, lamp is activated, but if I turn off the switch, nothing is happening. Why? Because I didn't write the script for off condition. So what you have to do? Again, you have to write the script like if SW equal to 0, then lamp is equal to 0. Now do the same here. In the next line, if SW equal to 0, then lamp equal to 0 and validate. Okay. Now if you go to runtime, see, if switch is on, output is on. If switch is off, output is off. Now in case it is immediately happening, right? But I need a time delay for this. I'm giving 5000 milliseconds. 5000 milliseconds means it is approximately 5 seconds. So see, validate, okay. Now if input is on, it will not get immediately activated. See. After 5 seconds only output is on. Same way, if input is off, after that, after some delay only, it will be deactivated. Okay, if it is on, it will take some delay. Again, if it is off, it will take some delay and turn off. Now you are doing two different conditions for this, like for off condition once you are writing, for on condition once you are writing. You have another type of syntax. It will be like if input condition, then output statement, semicolon, else another output statement. Or again semicolon here. Now see here what will happen if this input condition is satisfied, then one output will be executed. Else, if that input is not satisfied, another output will be executed. So how you will write for this means, you will write the same script, you will write like this. If SW equal to 1, then lamp equal to 1, semicolon, else lamp equal to 0 and F. Now I'm deleting this and I'm writing in that format. If SW equal to 1, then lamp equal to 1, else lamp equal to 0. And F. Validate. Okay. Now see here. If input is on, output is activated. If it is off, it is deactivated. So like this only you will write the script. Now here you have single input and single output. In case, just assume you have multiple inputs and multiple outputs. So for this I have given SW, and for this I am going to give SW2, and for this I am going to give SW3. So I am giving lamp2, here I am giving lamp3. Just assume here my condition is all the three inputs are on, then only this lamp should be activated. Only one output as of now. I'm not considering that outputs. I'm taking this as my output. If all the three inputs are on, output should be activated. So how you have to write this script means you have to write with AND condition. If SW equal to 1 space and space SW2 equal to 1 and SW3 equal to 1, then lamp equal to 1. And then here also you can write else lamp equal to 0. Validate. Okay. Now see here, any one input on, nothing is happening. If all the three are on, only output will be on. Now if any one is deactivated also, output will be off. Now in case I want to add all the three outputs here, how you have to add means you should not use AND, you should directly use in the next line, lamp equal to 0, lamp 2 equal to 1, lamp 3 equal to 1. Same way for off condition also, lamp 2 equal to 0, lamp 3 equal to 0. Now what will happen if all the three inputs are on, all the three outputs will be activated. If any one is on, it will get deactivated. So this is how you have to write the program for this. Now in case this is all the three inputs on, output is activated. Now in case any one of the input only on means instead of AND you will use OR. Validate. See, any one of the input is on, all the three outputs are activated. Now in case I have, this is SW, this is SW2, this is SW3, and I have another input. This is SW4. With this I'm giving. if either any one of these two should be on, okay, like this, these two, either these two should be on or these two should be on, then only output should be activated. If one from this and one from this on, it should not get activated. Either these two should be on or these two should be on. So how you have to write the script means these two should be AND condition, these two should be AND condition. In between these two, you have to write OR. So how you have to write SW equal to 1 and SW2 equal to 1 or SW3 equal to 1 and SW4 equal to 1. You see here, these two are on, nothing is happening. See, these two combinations are activated, it is on. These two are activated, at that time it is on. If this and this are on, nothing is happening. Okay, is it clear? So this is how you have to write the script for on-off conditions. Now in case I want the condition for logic gates, okay, so first and OR function we have seen. Now just assume I have S1, S2 and the lamp. So initially, if both are off, output should be off. 1, 0 only, it should be on. This is for XOR. I'm 0, 1, it should be 1. 1 and 1, at that time also output should be 1. Sorry, 0. So this is for XOR. So how you have to put the condition for this means so here this is SW and this is SW2. So you have to write the script for every conditions. So whatever conditions I have given, SW1, so SW equal to 1 and SW2 equal to 0. If switch 1 is 1 and switch 2 is 0, then only what should happen? Output should be activated, right? Then lamp equal to 1 and if like this I'm giving. Same way if SW equal to 0 and SW2 equal to 1, then lamp equal to 1 and if validate. Okay, now see here, initial condition it is off. If any one is activated, output is on. But if I deactivate, see, it is not returning. So what you have to do for off condition also, you have to write if SW equal to 0 and SW2 equal to 0, then lamp equal to 0. And Same way, if SW equal to 1 and SW equal to SW2 equal to 1, then lamp equal to 0. Validate. Now see here, initial condition it is off. If any one is activated, output is on. If I deactivate this, again returning back to off condition itself. If this is on also, it is off. Now if both are on also, see, it is off. So this is how you will write the program, like script for on-off condition. Okay, so in the next session we will discuss for analog condition also, like how tank level should be increased, how object should be moved in the conveyor. So that and all we will see in the next session. Okay, so
Sir, 2:30 shall we start, sir?
yes sir, we can start at 2:30.
2:30 to 4, sir, next session.
Yeah, so the next session will start at 2:30 till 4 o'clock.
The participants, please join at 2:30. In the meantime, you submit the feedback for first two sessions separately. Okay, so we'll see in after 2:30. Okay, sir. Thank you, sir.
Okay sir, thank you.
Participants, any doubt in the morning session? Hello. Okay, we'll meet at the afternoon.
Yes, friends. So already we have seen scripts for just the on-off condition. So if you have some condition like on or off, we'll use 1 and 0 and write the script for that. Now, in case, if suppose I have a switch, using this switch, I want to increase the level of a tank. Okay. So what I have to do for that? So for example, I'm giving the tag name for switch as SW, and for tank, I'm going to give the tag name as TA. So for switch, it is SW, and for tank, it is TA. So we have to follow the same syntax. By following the syntax, what we have to do, we have to write the condition. We have to write like if SW equal to 1, then TA, tank should be increasing gradually. That is, the level of the tank should be increasing gradually. So what I have to do, if suppose I give tank TA, tank tag name equal to 50, if I give like this, what will happen? Directly it will go to 50. If I give 100, what will happen? Directly it will go to 100. But I want it to gradually increase. So what I have to do, I have to increment it. So I am giving TA equal to TA plus 1. TA equal to TA plus 1. So what will happen means I'm giving end if here. So what will happen here is initially what is the level of the tank? It is 0. So 0 is equal to 0 plus 1. So what will happen now? Tank level will go to 1. So again it will check because I have given a time delay, 1 millisecond or 5000 millisecond like that. Based on the time delay, after the time delay, again it will check whether the switch is on. Still, if switch is on, what will happen? Again, the same condition will execute. So now what is the tank level? Tank level is 1. So 1 equal to 1 plus 1. So it will go to 2. Now again, if switch is on, what will happen? Now tank level is 2. So 2 equal to 2 plus 1. So it will be 3. Like that, what will happen? Till this condition gets satisfied, the tank level will be gradually increasing. Now in case after reaching 70, I have turned off the switch. I have manually turned off the switch. What will happen means the condition will not get satisfied. So automatically at 70, it will be stopped. Now in case here I have given 1, right? Instead of 1, I am giving 2. So what will happen? If switch is on, tank level will go to 2. After that, it will go to 4, then 6, 8. Like that, gradually it will be increased. So instead of this value, I can give any value. Like I can give 1, 2, 3. If I give 10, what will happen? First it will go to 10, then 20, 30, 40. Like that, gradually it will be increasing. Now I will show you how it is done in the software. So just assume I'm going to use the same switch. I'm taking a tank. So for tank, I'm giving the tag name as TA. So see here, for this I have given SW, and for tank I have given TA. So what I'm going to do, I'm going to Windows script, and here I have to write the script. If SW equal to 1, then TA equal to TA plus 1. And if you want to see the value, what you have to do is you have to type text. After typing text, you have to give the tag name of the tank. So for tank, I have given the tag name TA. So I have given the tag name. So now what will happen is if I go to runtime and if I activate the switch, what will happen is the tank level will be gradually getting increased. Now if I turn off the switch, see what happens? It is stopped there itself. Why? Because the condition is not getting satisfied. Now okay, it is continuously on. See, after reaching 100 also it is not stopped because condition is continuously executed. So what I can do is I can turn off the switch automatically. So what I can do is if tank level reaches, for example, I am giving TA greater than 90. If TA is greater than 90, then SW equal to 0. And if now see if I go to runtime, it is remaining in the previous condition only. So what you have to do, each and every time if you do any changes, you just close the runtime window and open it newly. Now see here, switch on. If switch is on, tank level is getting increased. Gradually it is getting increased. After reaching 91, what happened? Since I have given greater than 90, when it reaches 91, automatically switch is off. Now what I can do, gradually it is increasing. No? So after reaching 90, what happens? Tank filling is stopped. So what I am going to do is I am going to decrease the tank level again. So I can write that in script. If SW equal to 0, I am writing and T is greater than 0. Sorry, TA is greater than 0. That is, if switch is off and the tank has some level in it, then tank level should be decreasing. Then TA equal to TA minus 1 in depth. Now see what is happening. I am closing this window viewer. If switch is on, tank level is getting increased. So what happens after reaching 90, automatically the tank level is getting decreased. So it has reached 0. Again, if I turn on the switch, it is continuously increasing. Now what I can do, it is decreasing and stopping now. Again, if you want, we can start that also. Like if TA equal to 5, that is, while decreasing, if tank level reaches 5, then SW equal to 1. Automatically it should be on. Now see what happens. Tank level is getting increased. After reaching that value, it is getting decreased. After reaching 5, what will happen? Again, it will be getting increased. So like this, continuously it will be happening. Now, I am increasing and decreasing the tank level here. Now what I am going to do, I am going to take a switch. I am taking a conveyor. So I have taken a conveyor here. I want to move an object in the conveyor. This object I want to move in the conveyor. So what property you have to give? You have to give the measurement here. So it is nearly 295. Till this distance means it is 966. So it is approximately around 600. So what I'm going to do is I'm going to give horizontal movement 0 to 100. I'm giving approximately 600. I'm giving, and here I'm going to give the tag name as okay. I'm giving the tag name as TA. So for this, I'm giving the tag name as TA. For this, I'm giving the tag name as SW. So if SW is on, TA should be automatically moving. So this is my condition here. Now see what is happening. I'm going to write the script for that. If SW equal to 1, then TA equal to TA plus 1. Because here also it should be gradually increasing, right? So gradually it will be increasing. So what you have to do, the same script only here also I'm going to write. So what will happen if switch is on? switch is on, see automatically the object starts moving. Now after reaching this position, object is stopped, no? So automatically it should come back. That also you can write. So what I can do here is go to script. If TA is greater than, I'm giving same 90, then T SW equal to 0. And if now if SW equal to 0 and TA is not in that initial position, it is more than the initial position, then TA equal to TA minus 1. And see, whatever script I have written for tank, the same script only I am writing here also. Only the property I have changed. For tank, I have given filling property. For movement, I am giving location property. Now see what is happening. Switch is on, tank level is getting increased. After reaching this level, automatically switch will be off and object will go in the reverse direction. So this is how you will write the script. Now, for this object, what property I have given? Horizontal movement property I have given. For the same object, if I give vertical movement, see vertical movement I am going to give. I didn't change anything in the script. Same script only I am going to give. See what is happening. If I turn it on, see the same object is moving vertically. So the change is only in the animation, like the property what you are giving. But the script is common only. For any kind of thing, you can write the same script. Now see, instead of vertical movement, I am going to write orientation. Orientation means rotation. Now see what is happening. If I turn on the switch, so the object is rotating now. So now we will see this with different examples. Okay. Now I am going to have two tanks like this. So we can consider like switches on, this tank level should be increasing. After that, the water from here only, that water is only filling this tank. for both the things, I am giving a name. So here I am going to give vertical filling. So this is TA. Tag name TA I have given. For this I am going to give TA1. So two tanks are there. One is TA, another one is TA1. So if this switch is on, automatically this tank level should be increased. For that I have to write this script. If SW equal to 1, then TA is equal to TA plus 1. And now what is my condition is, after reaching some level, after reaching this level, the water from this tank should be filling this tank, no? So what I'm going to do is, if TA is greater than 100, then TA1 is equal to TA1 plus 1. And now see what is happening. If I turn on the switch, first this tank will be increasing. After reaching 100, automatically this will be increasing. So like this, for multiple tanks also you can write the script based on the requirement. Now I'll say another example. Just assume there are two tanks. I have sensors here. So this is low level sensor for first tank. This is low level sensor for second tank. These two are high level sensors. So for this I have given the name as TA, and for this I am giving this TA1. Now what should happen is, if switch is on, automatically the first tank level should be increasing. Okay, so for low level and high level, this sensor should be doing the function. So if SW equal to 1, then TA equal to TA plus 1. And now if TA is greater than 90, then SW equal to 0. And now what I'm going to do, if SW equal to 0 and TA is greater than 0, then what should happen? TA equal to TA minus 1. It should be decreasing. Now this is my condition. Okay, so for that I'm going to activate the sensor also. So for sensor also I have to give the tag name now. So I'm giving blink property here. So I'm giving LLS, low level sensor 1. Low level sensor 1 as the tag name for this. And for this I'm going to give the tag name as high level sensor 1. So for that, if TA is greater than 10 and TA is less than 20, simply for assumption I'm writing. Tank level is 10 to 20, then LLS1 equal to 1, else LLS1 equal to 0. And same way for high level condition. If TA is greater than 80 and TA is less than 90, then HLS1 equal to 1, else HLS1 equal to 0. And validate. So see here, if I go to runtime, for second tank I didn't do anything. Now if switch is on, see what is happening. Sensor is on and off. Same way at high level also sensor will be on and off. See, it was blinking and it is decreasing. Now what I need is, when this tank is decreasing, this tank should be increasing. So for decreasing, I have given the condition here. If switch is off and if tank level is greater than 0, then TA equal to TA minus 1 I have given. So in the next line itself, I am giving TA1 equal to TA1 plus 1. So what will happen there? At the same condition, this tank level also will be increasing. See, if switch is on, this is increasing. When it is decreasing and the first tank is decreasing, the second tank will start increasing. See? Now what I need is, again automatically switch should on. If switch is on, this should be increasing automatically, this should be decreasing. So what I can do is, if SW equal to 1 and TA1 is greater than 0, then TA1 equal to TA1 minus 1. Previously we have given minus condition for this no first tank. At that time switch is off, but here switch should be on. So what I am going to do, if TA equal to 10, if tank level reaches 10, then automatically switch should be on. Like that I am going to do. So what will happen here is, I give validate and OK. Switch is on, tank level is getting increased. After reaching that level, second tank is increasing and first tank is decreasing. Then again after reaching some level, see, automatically it got increased. So continuously like this it will be happening. So even for this sensors also you can write the condition. So this is normally for a tank filling process. Now I'll give you an example with conveyor. So I'm going to take sensors here. I'm taking motor here. This is forward motor, and another motor I'm going to take and keep it here. This is reverse motor. Now for all the objects I have to give tag name. So I'm having two switches. So this is for forward direction and this is for reverse direction. So I'm giving SW here, and for this I'm giving SW1. I'm giving SW2. So this is SW and this is SW2. So for sensor I'm going to give sensor 1, and for this sensor I'm going to give the name as sensor 2, and for motor I'm going to give it as FM, forward motor, and for this one I'm going to give the name as RM, reverse motor. So now what is my condition is, if this sensor and if this switch and this sensor is activated, motor should be on. If motor is on, object should be moving in this direction. After that, when this sensor is on, motor should be off, so object should be stopped. And already this is on. If I press this reverse switch, object should come in reverse direction so that this motor will be on. So that is my condition here. So first what I have to do, I have to write the condition. So here I have to only manually activate the sensor. So I'm giving user input for sensor 1. So user input means what you can do, you can double click this sensor and activate it. So for this I'm giving it as sensor. If SW equal to 1 and SCN1 equal to 1, that is switch 1 and sensor 1 are on, then what should happen? FM equal to 1, that is forward motor should be on. End it. Now if FM equal to 1, forward motor is on, then for object I have given TA equal to TA plus 1. So see what is happening here. see what is happening if I go to runtime. If I activate this first switch, still it is not activated because sensor also should be on. Now if I activate this sensor, see motor is on, so that object starts moving. Now if this sensor is activated, what should happen? Motor should be off. So I have to write that in the program. If SCN2 equal to 1, then FM equal to 0. Now see. This switch is on, and if I activate this, see forward motor is off. Now if this is activated and this switch is activated, reverse motor should on and the object should move in the reverse direction. Now I'm going to give that. If SW2 equal to 1 and SCN2 equal to 1, then reverse motor RM equal to 1. And if RM equal to 1, then TA object equal to TA minus 1. Now see here, if this switch is on and if this sensor is activated, object is moving. If I activate this sensor, object is stopped there itself. If I activate reverse switch, see this motor is on and object moves in the reverse direction. So here, since it is just a demo application, I am giving the input here. Okay. But in the real time, automatically sensor will be activated. Now, if this sensor is on, what should happen? This should be deactivated, right? So that also we can write in the program. Then this motor also will be off. Okay. So this is how we have to do the program in SCADA. So with the help of script, this is how we will be designing the process in SCADA. Next, we are going to see about a topic called recipe. So generally, what is the meaning of recipe means? Normally for food preparation and all, we will be using recipe book or any kind of recipe and follow that. So what will be mentioned in that means it will be having the ingredients quantity. What are all the different ingredients we are going to use in that, and what is the proportion of the ingredient? For example, I want to make coffee. Okay, so in coffee, I'm going to have three different things. It is I'm going to mix sugar, I'm going to mix milk with the coffee powder. So in that itself, I have light coffee, medium coffee, strong coffee, like that. So ingredients are same only. For that also, you're going to use coffee powder, milk as well as sugar. But what should happen? The concentration of the ingredients, like the proportion of the ingredients, should be increased or decreased. So in industries and all, the same thing only will be used. What they will do, they will not use each and every ingredient separately and mix it separately like that. So they will be keeping all the ingredients and the proportion in one in this recipe manager. There will be an option in SCADA called recipe manager. In recipe manager, what they will do is they will create all the recipes what they have. For example, strong coffee this much, light coffee this much ingredient, like that. So I will say this with the example of medicine manufacturing. Okay, like I have a medicine. For medicine 1, calcium this much percentage, potassium this much percentage, magnesium this much percentage, zinc this much percentage. For medicine 2, the same ingredients only I am going to use, but at some other proportion. Okay, just for example I am taking. Okay, so I'm having 3 different ingredients. So I'm having paracetamol 250 mg. Next, paracetamol 500 mg. Just for understanding purpose, I'm doing like this. Paracetamol from 650 mg. Like this, 3 different ingredients are 3 different recipes are there. This is nothing but recipe. This is recipe 1, recipe 2, and this is my recipe 3. So what I'm going to do here means, so for paracetamol, just I'm mentioning zinc. Some paracetamol 250 mg. No? So for that, zinc is 30 milligram. Calcium is 50 mg. Potassium 100 mg, like this. Just for example, I'm mentioning like this. So 3 different ingredients I'm using, but ingredient ratio are different. Here it is 30, 50, 100. Same way, if I use that here, for example, it is 500 mg. So zinc will be 50%. So this is 75%. And potassium I'm mentioning 18 milligram, like that. Same way here. So what is the difference here means ingredients are same, but the ratio of the ingredients are different. So each and every time, no need of sitting and doing this separately. I can keep all these things as my recipe in recipe manager option. So what is the use of recipe manager means? We can create different recipe for the production of process, and we can activate that recipe to recall the values available in that, and according to that the process can be controlled. For example, I am giving for this switch recipe 1 should be activated. For this switch, recipe 2 should be activated. For another switch, recipe 3 should be activated, like that. I can do all these things together. So where you have to do all these things means in SCADA, you have an option here called application. Under tools, you have an option called application. Okay. So click on that applications and you have that option called recipe manager. Okay, so double click that recipe manager, and here if you see recipe manager option is available, go to file, select new. Go to file, select new, and here if you see three different options are available. One is unit definition, another one is template definition, and the other one is recipe definition. Here only you have to create your recipe. So first what you have to do, you have to mention what are all the ingredients. So in template definition, you have to mention the ingredients. So in my process, the ingredients are zinc, calcium, and potassium. Now ingredients type, all these things are analog only. So I have to type analog. Because it is a ratio. Ratio means it is not digital, it is analog. So zinc, calcium, potassium I have given. Next, after doing this template definition, just minimize this. Next, you have to go to unit definition. In unit definition, what you have to do means you have to give separate tag name for every ingredients. So for zinc, I am giving Z as the tag name. For calcium, I am giving C as the tag name. For potassium, P. So this is what you have to use in the SCADA design also. For all these things, commonly I am giving one unit name also, U1. So I am giving unit name here. Next, for zinc, I have given a tag name. For calcium, I have given C as the tag name. For potassium, P, like that. Next, in recipe, here only you have to mention what is your recipe and what are all the ingredients quantity. So I am mentioning paracetamol 250 mg like this. And for that, I am giving zinc, calcium, and potassium how much. So for that, zinc is 30, 50, 100. So next, recipe 2 is there, no? In that, you paracetamol 500 mg. So I'm going to give 50, 75, 80 like this. So whatever I have given here, that only I'm using there also. Next here, paracetamol 650 mg. $75. Here I'm giving 100 and here I'm giving 150. So after giving all these things, what you have to do, you have to save this file, save as, select a location where you want to save that, give a name. So I'm just naming it as medicine. So after that, if you select save, see here it is showing the location where it is saved. In C directory, it is saved medicine.csv. So you should not forget this because this we will be using in script also. So in script, that is in designing the process, what I have to do is I'm just using 3 inputs. Like I'm going to use 3 switches here. So here I'm naming it as SW. For this I'm naming it as SW2. For this I'm naming it as SW3. Totally 3 switches are there. This switch is for 250 mg. This switch is for 500 mg. And this switch is for 650 mg. Totally 3 switches I'm using. So I want to display the level like zinc how much. So I'm going to display it here. Zinc is equal to, in this hash only it will display the value. Same way here, calcium is equal to how much. Next, potassium equal to how much. Now for this, as I said earlier, already we have said like we have to use this tag name only because I have given the tag name, that tag name only here. So for zinc, what tag name you have to give is Z, for calcium C, and for potassium P. So these three tag names only you have to give for that process. So double click this zinc, give value display analog, and give Z as the tag name. And for calcium, C as the tag name. And for potassium, I'm giving P. Now what I have to do after doing all these things, you have to write the script for this. Like if switch is on, it should take the recipe from this place and it should show the values here like that. So I'm going to Windows script and I'm going to write the script for that. If SW equal to 1, then you should not type anything here. Directly go to functions all. Directly go to functions all, and you have to find here recipe load. You can see here, right? Recipe load. If you click this recipe load, automatically it is asking for file name. That is, which file it should take. So I have stored all the recipe in this file only, c:/medicine.csv. So this location I have to type here. You have to type in double quotes, c:/medicine.csv like this. End with double quotes. Same way here, it is asking for unit name. Double quotes U1. So U1 only I have given there. See, U1 is the unit name what I have given here. So give U1 double quotes. Next, recipe name. What is the recipe associated with first switch? It is here only I have given. See, first recipe name is paracetamol 250 mg. So I have to give that here in double quotes. Next, after this, you enter. Now repeat the same for next switch. If SW2 equal to 1, then go to functions all. Same, click recipe load. It is asking for file name. Here again type c:/medicine.csv double quotes. Same unit name only. In case if you have many different processes, you will have different unit name. Unit 1, but now recipe name is different. So now the recipe name is paracetamol 500 mg. So I'm giving that. And next, if SW3 equal to 1, then recipe load c:/medicine.csv. Here I am giving unit name. Unit name as U1. Next, the third recipe is paracetamol 500 mg. sorry, 650 mg. Double quotes. Now after this, give validate. Okay. Now if you directly go to runtime, just if you turn on the switch, it is enough. Automatically it will show the values. So for first 250 mg, it is showing zinc 30, calcium 50, potassium 100. So here, since it is normal simulation mode, it is just showing here. But in the real time, what will happen? This 30 will be linked with the program. So whatever program I am doing in the PLC, after interfacing that, this value will be going to PLC. So according to that value, PLC will control the process. Same way here, 500 mg means the value is getting changed. Next, this means according to that, it is changing. So this is how what will happen is the process will be getting controlled for recipe. I can create multiple recipes like this, and in script you have to just change the file name. That's all. So according to the changes what you have given, it will be getting executed. So that's all about script. Next, all these things we have did in just simulation. Now we will see how to interface PLC and SCADA. Okay. So how will you interface PLC and the SCADA together? Now just assume, for example, here I'm using one PLC and I'm going to use SCADA. So what is the process? How to interface all these things together like that, and we will discuss now. And just assume this is your SCADA PC. SCADA PC, or you can take it as control room process. Now just assume my field process is like this. So I have a conveyor, I have a motor here. I have an object here. I have sensors. So this is sensor. This is sensor 1. And there is another sensor here. This is sensor 2. So based on the requirement, if sensor 1 is on, motor should be activated. If sensor 2 is on, motor should be deactivated. So I have to connect the sensor 1 and the sensor 2 in the PLC's input. So next, motor should be the output of PLC. Now what I have to do in SCADA, one by one we will see. First, what we have to do in SCADA means, okay, first we will see about programming. In PLC, how the programming will be means, if sensor is activated, motor should be on, right? So for sensor, I am giving normally open, I am going to connect it with the motor. So this is sensor 1. I'm going to give it to motor. I'm latching it with the motor. This is sensor 2. So if sensor 2 is on, what will happen? Automatically motor will be off. So this is my program. Now in case, just assume I'm using ABPLC here. For ABPLC, the input address is I:0/0. This is the input address. Second input address is I:0/1. Next for motor, it is O:0/0. And for this, same O:0/0. So I have given the process like this. Input, two inputs I have given. Motor I have connected. Next, what I am going to do is, first what you have to do in SCADA, you have to design the process. Design the process in SCADA. So same like your field process design, you have to design it in SCADA. So after designing, what you have to do, you have to give the tag name. In tag name only, you have to give the address also, right? So in place of this tag name, for example, I am giving the tag name for this as S1. And in S1, what you have to do, you have to give the address also, I:0/0. Same way here for this, I am giving it as S2. For this, I have to give it as I:0/1. Same way for this, I am going to give M as the tag name, and for this, I am going to give O:0/0. So all these things I have given, but what will happen? It will just show the indication like blink property, visibility property, like that. If I give some property, according to that, it will be functioning. But object, when it will be moving, means for object movement, you have to write the script. So for this separately, you have to write the script. So what script can be written means, if motor equal to 1, then for example, for object, I am giving OB as the tag name means OB equal to OB plus 1. And so for motor, the tag name I have given as M only. So no need of writing the script for sensor and all. Okay, because already for that and all, we have the program in the PLC. Only for object movement, we don't have that program. So for that only you have to write the script. Remaining for all those things, automatically it will take from the PLC program. So in program, if the sensor is on, here also it will show the status. So how it will show the status means, from PLC, it should be communicated with the PC here. So for this, they will be using one software called IO driver software. So using this IO driver software, what we can do, proper communication will be between this PLC and the SCADA. So this is how you have to interface PLC and SCADA, and you can monitor, you can control or collect the data from the SCADA. So now one by one, how it can be done with PLC programming, how it should be done, SCADA designing, and how the process can be interfaced. I will explain you. So in AV PLC software, you have to do the programming. So the software is RS Logix 500. So in this software, I'm going to do the program. So in this I:0/0, I have given the input address. Next input address I:0/1. Stay here O:0/0. O:0/0 like this I have given. Now after this, I said one IO driver software is required for communication, right? So normally if you run this program, you can test it, like if input is on, see output is activated. Even if you turn it off also, continuously output is on. If sensor 2 is activated, it is deactivated. Now in IO driver software, the IO driver software is RS Linux Classic. In this IO driver software, what you have to do, you have to go to this DDE topic configuration. Go to DDE, select topic configuration. So in this, for example, see, I'm going to save it. Processor name it is showing now. So I have just given the name as untitled. Okay. So the same name only will be shown there also. If you see here, see under untitled, the PLC model number which I have selected, it is showing here. Micrologix 1500 untitled. So what you have to do, you have to just select that. Okay, just select that. Give apply and select done. You apply and select done. Now this is selected. After this is selected, now you have to open InTouch SCADA and design the process. So what I'm going to do is same like our field design here also I'm going to make that design. So I'm going to take a conveyor here. I need two sensors, okay. I'm keeping the object here. So same like your field design, you have to take a motor. Now I have to give the tag name for all these things. So for motor, I'm giving the tag name under link property MOTOR. This I have given. Next for sensor, same link property, I'm giving sensor 1. Same way for this sensor 2. Now next for object, what you have to do, I'm giving horizontal movement property. So just see here, just keep the cursor, it is 330, till this object should be moved means it is 950. Approximately it is around 600. So here I am giving OB as the tag name for horizontal movement. So it is 0 to 100. So all the tag names I have given. Now in the tag name, what I have to do, I have to specifically mention the address. So how to mention that means double click the tag name here in sensor 1. If you double click here, this page will get open. Here it is showing as memory discrete. Memory means simulation mode. If it is interfacing between PLC and SCADA, you have to change this as IO discrete. After changing it as IO discrete, what you have to do is go to access name, select access name, choose the option add. And here in access name, you can give any name. For example, I'm just mentioning PLC. No need of giving any node name. Application name is nothing but the IO driver software name. What is the IO driver software name means? It is RS Linux. So just type RS Linux. And topic name is nothing but the topic what I have given here. What is the name of the topic? It is untitled. Just give that name. So I have given that name here, and it is asking us which protocol to use. Change it as DDE and give OK. Close. Now in item here only you have to give the address. So this is sensor 1 no. So for sensor 1, what address I have given? I:0/0. So that address you have to give I:0/0. After that, save, close. Next, do the same for sensor 2. Double click this. Change from memory discrete to IO discrete. And here, you have to give it is I:0/1. Next, to do the same for this motor also. For output, it is O:0/. Now see here, I'm not writing any script. Directly, I'm going to runtime. I have completed all these things. I didn't write anything in the script. Just I have it like this. I cannot do any activation or anything in this page in SCADA. all these things are gathering the information. In simulation only we can activate, but in this I have given the control with the PLC. So in PLC, based on the input, if it is off, here also it is showing off. Now see, if I am activating this input, I'm just activating in PLC. Okay, if I activate it, so what is happening? Output is also on. Can you see here? If I activate there, automatically sensor is activated here, motor is also activated. Now if I deactivate that sensor here, still motor is on. If the motor is on here, the same data will be received here. See, motor is still on. Now if I activate sensor 2, sensor 2 is on, motor is off. If I deactivate it, here also it is deactivated, but object is not moving, right? So for object movement, it is animation. So what you have to do, you have to write the script for that. Go to Windows script, you have to write if motor, okay, if motor equal to 1, then OB equal to OB plus 1. So see here, now I am selecting runtime. Now if I activate the input here, see what is happening. Object starts moving. Even if I deactivate here, continuously the object has moved and reached here. Still motor is on. If sensor 2 is on, what will happen? Motor will get deactivated. So if sensor 2 is on, motor will be getting deactivated. So this is how I have the process here. Now for example, I'm going to do another program for this. Like I'm going to keep another motor here. So I'm going to give motor 1 like this. I'm giving the name here. I'm going to change it as IO discrete O:0/1 like this. So what is the condition here? Means if sensor 2 is on, this motor should be on. If this motor is on, object should move in the reverse direction. So I have to do the change in the program also here, PLC program also. So which is sensor 2 I:0/1, right? So I:0/1. If this is on, this motor should be on. O:0/1. This should be on. I'm latching it because even if it is off also, continuously it should be on. So I'm giving that address here. Now here I have given if sensor 1 is on, this motor should be off. Same way, sorry, sensor 2 is on, this motor should be off. Same way here, if sensor 1 is on, what should happen? That should be off. So what I have to do here means put on NC and type sensor 1 address. Sorry, sensor 1 address. Now what is the condition? If sensor 1 is on, forward motor will be on. If sensor 2 is on, forward motor will be off and reverse motor will be on. If again sensor 1 is on, process will be stopped. So for this, I am doing some modification in the SCADA design also. So here I have given motor 1, right? Directly giving runtime. See, I didn't change. I did the changes here. If this sensor is on, according to the program, what will happen? See, this is on, motor is on. If I deactivate that particular input, what will happen? Still motor is on, it has reached here. If I activate this sensor, what should happen? This motor is on and that motor is off. See, this is activated, this is off. When this is activated, object is not moving in reverse direction. Now, why it is not moving means I didn't write the script for that. Okay, so just right click, Windows script. I have to write if the condition for that is motor 1, no? So Windows script if motor 1 equal to 1, then OB equal to OB minus 1. And validate. Okay. Now if I go to runtime, now see here, if I activate this sensor, what is happening? It is activated. Even if I deactivate also, continuously it is moving. See, sensor is off, it is continuously moving. Now if I activate this sensor, what will happen? This is on, so object should move in the reverse direction. See, it is moving. Even if I deactivate this sensor also, continuously it is moving. So now this is for on-off condition. Now, for example, just assume I have a tank here. Using hash, I have a tank here. I want to give the input for this tank from PLC. Okay, so I'm giving the name as tank. So for that, first I have to do the program, right? So go to PLC program. So I'm going to use comparator block or move block. Okay. So using move block, what I'm going to do is I'm going to give the address there. N7:0, N7:1. This is the address for analog. Okay. Now I am downloading this. So whatever value I give here in the move block will be reflected there in SCADA. See, now it is 0. So how it will be reflected there means in the tag name I have to now change this as IO real. Select the access. I'm giving N7:0. See here, if I go to runtime, same I'm giving here also. It is 0 here. Okay. Now, if I give, for example, I'm giving 50. Now see here. Here also it is showing 50 and it is 50% filled. If I, for example, I'm giving 75. So whatever value it is available in the field, that value will be reflected here also. Now from this also I can control that. No, how you can control means instead of this value display envelope, I am giving this one. User input. Now see what is happening. It is showing the value. Now it is showing 75. If I click here, I am changing it as 25. Here also it is changed. Same way. See, in PLC program also it is changed. So what I can do, I can access the memory from SCADA and I can monitor the process as well as control the process from SCADA. So this is how you will interface the process with PLC and SCADA. Okay. So I think what all the topics we have seen today is clear for you. So if you have any doubts related to this, you can ask me now.
Sir, Mushtinga sir. Participants, if you have any doubts, you can raise. So from the morning till the evening, Mr. Subash has handled the SCADA sessions very nicely. So I request the participants to make use of this availability. Participants, no doubt. If there is no doubt means then we can I think close. No? So I, on behalf of our institution, I thank Subash sir for handle a wonderful session on SCADA application architecture, applications, and how to develop an application using SCADA, and interfacing PLC and SCADA also he has covered. So I thank Subash sir for his wonderful presentation on SCADA, and thank you very much sir for your presence.
Thank you, sir.
Okay, participants, thank you. We will meet tomorrow morning.